Sorry, everyone. See what a bright smile you have. Yeah. Even though the good news is I graded the exam, the bad news is many of you failed. Many of you. Which is kind of surprising because factoring should be the easiest one. So even without the exponent rules, just with the factorings, for some people, the first page was easier. They got the highest score in the first page and got almost 0 on the factoring. For other people, they got good score in factoring, but got really bad score in the first page exponent rules. So it is weird. But anyway, I'm going to give you an exam back later toward the end of the class. And also, I didn't make the review sheet yet, but my plan for your exam, for next exam, is to make the review sheet by tonight so that you have your review sheet to start studying. And when is your exam? Do you remember? Exactly 1 week from today. Next week, Tuesday. Yeah, after Tuesday. After Tuesday, we are going to go on a break for 2 weeks. For 10 days, actually. For 9 days, actually. But my morning class, they were like, oh, do we have to come back on 10th, which is Friday, and have a class? So they are hesitating. So I was being nice. I decided to give you another off day on 10th next week. From 1 to 10, we are going to have a break. You don't even have to go to PLTL. I'll tell PLTL leaders to give you off day. Thank you. Okay, but you have to watch a recording instead of coming to the class. So I'll give you a recording with the new materials. So you have your spring break till 2 weeks to watch the recording. Please watch it so I can at least tell the department, like if I get into trouble, I can tell them, well, we had asynchronous class. We did not have in-person class. Okay.
You say that many of the class fail. Maybe the department will make something.
No, that's why I decided to give you the text correction.
And it's also 10%.
10% of whatever you lost. Whatever you lost in the exam, you get 10% off that score by doing the entire review sheet. Not review sheet, sorry, entire exam. This exam was short, so you should do entire thing, plus all these things are factoring, and you're going to need factoring in everything you're going to do from now on. So the entire chapter 7 is factoring, and then we have chapter 10, 11, factoring. See, factoring. So you should know how to factor 2 terms, 3 terms, 4 terms. Let's start, and then I'll give you your exam later. And you're going to do a reflection, but not today. You're going to do the reflection in the next class, in class, or maybe Friday. Friday actually will be a good day to give you the reflection. And I should get the reflection in person because I'm supposed to scan them and then submit to the department, the exam reflection. So, last class, we started simplifying. Let me refresh your memory with what we did in chapter 7. We started chapter 7 with rational expression, and we did evaluating rational. This will not be in the exam because we have so many other important stuff to put in the exam. Then we talked about domain, and I already tested your knowledge on domain in exam 1. So I'm going to skip domain for this exam. And then we talked about simplifying rational, and we said there are 3 steps to simplify. One is factor everything, whatever is factorable, cancel any common factors you have, and then rewrite the remaining factors on their proper position. And then we did few examples, And now let's do one more example before we move on to the next topic. The directions is simplify, and we have x cubed plus 11x squared on the numerator, and x squared plus 8x minus 33 on the denominator. Terms, what do you do? How do you factor? X plus 11, x minus 3, the denominator. Good. So 3 terms we use direct factoring. Who would like to try the numerator? It is the denominator. Joshua? Which method? GCF. So 2 terms has only 2 choices, either GCF or perfect square. So what is our GCF here? X squared. After factoring GCF, what is left? X plus 11. So step 1, factoring whatever is factorable, we did that. Now what is our step 2? We have x plus 11, x plus 11. They both are same term. So we cancel. And then the last step is rewrite. So what do we have left on the numerator? Good. And on the denominator? Perfect. So we just write them in their proper position. And that's it. Factor, cancel, rewrite. We can always cancel if you have a multiplication sign between 2 factors. Between x squared and x plus 11, we have a multiplication. That's how you could cancel. Also between x plus 11 and x minus 3, we have an invisible multiplication, so you could cancel. Now here, at the end, we have x squared and x. Can we cancel them? Why not?
One have the power of 1 and all the power of 2.
Not because of that. The answer is correct, but the reason is wrong. Not even for the position. You are missing the very important thinking. Very important reason.
Because it's irrational.
Not because it's rational. Because x has a plus or minus sign next to it. Next to it. Not cancelable. Because anytime you have your next thing is plus or minus, you cannot cancel them. We could cancel x plus 11 because next to x plus 11, we have a multiplication sign. We could cancel this x plus 11 because next to that x plus 11, we have a multiplication sign. But next to this x, do you have a multiplication sign? So you cannot cancel. If you don't have a multiplication sign on the left or on the right or in both, then it cannot cancel. Okay, now that leads us to our next very important topic, negative. What if your fraction has a negative? What does it mean? Anytime you have a negative in the fraction, it's your choice where to put the negative. You can put the negative in the front, or you can put the negative on the numerator, or you can put the negative on the denominator. So negative has 3 choices on its position, for its position. The front, the numerator, or the denominator. But it definitely cannot put double negative. Why not? Because anytime we have double negative, that turn into positive. So if you originally start with a negative, there is no way you can get a positive at the end. So that's why the negative in the front belongs to either on the numerator or on the denominator, but definitely neither, not on both numerator and denominator. That takes us to a homework question. This is a homework question. It says write all the equivalent expression for this negative fraction. So here they put negative on the front, and we have x plus 3 on the top, 5x minus 4 on the denominator. So this is one expression given to us. Now, if you want to put this negative on the numerator, you're allowed to do so. You can put negative, but if you do that, since we have more than one term on the numerator, you have to put a parenthesis. We get x plus 3, and on the denominator, we have our same denominator, x minus 4. These two expressions are same. Or let's say you said, no, I'd like to put my negative on the denominator. No problem. You're allowed to do so. But if you do that, you have to put a parenthesis on the denominator. And your numerator stays same. So wherever you put the negative, that has to get a parenthesis, a set of parentheses. So all three things are same, they're equivalent. Also, if you want, you can distribute the negative on the numerator. So you get one more equivalent expression, negative x minus 3, and the denominator is 5x minus 4. The denominator doesn't change, but all the sign on the numerator, they change. Or if you want, you can distribute this negative on the denominator. So you get negative 5x on the bottom and positive 4. And on the numerator, you have the same thing. So wherever you are putting your negative, all the terms on that position change their sign. So all 5 expressions, they're equivalent. They are same thing. They just look different, but they are same. It's like you have 5 different names. First name, middle name, last name, nickname, house name, friend's name. Like same person you, but just different names. Well, why do we care? Well, we care because depending on your negative, we may be able to cancel something or we may not be able to cancel something. For example, these two expressions. On the numerator, we have x plus 2 on the left one. And on the denominator, we have 2 plus x on the left one. So if you observe this x plus 2 and 2 plus x, our x is positive on the numerator, x is positive on the denominator. So x has same sign. Similarly, let me change this to that. We have positive 2 on the numerator and also positive 2 on the denominator. They are same. So if you have same sign, then you don't have to, then we can just rewrite them. X plus 2, x plus 2. Because they are same thing. They are plus sign. Justin, question?
How would you choose the subtract the x at the top? No, correct.
Why you want to subtract? If you're trying to use the exponent rule, you can only use exponent rule in multiplication. See here, x is a plus sign next to that, so you cannot do the exponent rule or cancellation. So basically, these two expressions are same. They just wrote differently. Like 1 plus 2 is same as 2 plus 1. They're same thing. In addition, the position doesn't matter. But now, do you see the exact same two things on the numerator and denominator? So can you cancel them? What is left after the cancellation? No. Canceling means divide. So if you divide x plus 2 by x plus 2, the answer is 1. The answer will be 0 if you subtract them. We didn't subtract them, we divide them. In division, we get 1 always. So see, they look different, but since they have same sign, we can cancel them and we get 1 back. If you compare that with the next example, look what happens to the sign. X is positive on the numerator, but what sign X has on the denominator? Negative. So do they have same sign? X has different DE. I don't even know how to spell different. Let me rewrite. Different signs. Now let's look at R2. What sign 2 has on the numerator? And what sign it has on the denominator? So do they have same sign? 2 has DEFFERENT. Different sign. So our factor have only 2 terms, x and 2, and they both have different terms on the numerator and denominator. Now, let's say we want to have them same sign. So you keep our numerator, x minus 2. If you want to have the same sign, can you factor out a negative from the denominator? You can always factor out a negative from everything. So if I want to factor out a negative, I'm allowed to do so, no problem. But then what happens to the sign for the 2 on the denominator? So finally, 2 has a positive sign. If you take out -1 as a common factor, means you're dividing. If we divide 2 by -1, what sign 2 is going to have? Huh? So you have 2 minus x, and we factored out -1. Means we are dividing by -1. So we get -2. And what happens to the x, the negative x? It becomes positive x. What do you notice in the numerator and denominator?
No, they have the same sign.
They're the exact same 2 things. X minus 2, x minus 2. So can you cancel them? X minus 2, x minus 2. So what is left after the cancellation? Good job. See this -1 here? So why do we doing all these things? Why do we care? Well, we care because when the terms in the factor have, all the terms in the factor have opposite sign, we are allowed to cancel them, but after the cancellation, we get -1 as our result. We can divide them, but the quotient will be -1. Where if we have all the terms same, all the terms have same sign, then we can cancel them, but the result will be +1. So if you have same sign in every term in your factors on the numerator and denominator, even though the position looks weird, but we are allowed to cancel them, the result is 1. If you have the exact same 2 things with opposite sign, or exact same many things with opposite signs for every term, we are allowed to cancel them, but the answer will be negative. For example, if you have, let's say, x plus 2 divided by x minus 2. Can you cancel this time? Let's compare x. X has same sign or opposite sign? They both are positive, right? So X has same sign. How about your 2? What type of sign 2 have? Same sign or opposite sign? So X, same sign. I should write nicely. X has same sign. 2 has different signs. The rule says you have to cancel, you have to have same sign for everything or different sign for everything. So these two have same sign, we can cancel. These two have opposite signs, we can cancel. But here, one of them has same sign, the other has different sign. Can you cancel? Not cancelable. Not cancelable. So this is the rule. Cancellation is possible or permissible if all the terms in your factor have same sign, like x plus 2 and 2 plus x, or if all the terms in your factor have opposite signs, then the result will be -1. The compare numerator and denominator, same term, same sign, same term, same sign. So we can cancel them even though the position is wrong, but you can still cancel them, the answer will be 1. On the other hand, same term with opposite sign, same terms with opposite sign. So we are still able to cancel them, but the result will be -1. Why? Because in order to cancel, we have to factor out -1 from either numerator or denominator, from one of the places. And once we do that, we can cancel the rest. The result is that -1 factored. For example, if you have a plus b plus c, and you're dividing by, let's say, b plus c plus a, can you cancel these? Yes, because they all have same sign. A is positive, B is positive, C is positive. Same thing, A is positive, B is positive, C is positive. All of them, they have same sign, they have same factors. So we are allowed to cancel them, then answer will be 1. But if we have, let's say, A minus B minus C, and we have, let's say, -B, -C plus A minus B. How about this time? Can you cancel them? How about C? So first thing you notice is, do you have same ABC? Yes, ABC, ABC. Then you notice their sign. A is positive on the numerator. What?
I have a question. This one doesn't make sense because the A is positive and they cross out and the others are negative.
This one should be here. A minus B minus C minus B plus minus C plus A minus B. Let me write this here. So we have ABC, ABC, that matched. Then the sign, A is positive, A is positive. Good, same sign. B is negative, B is negative, same sign. Good. C is negative, C is negative, same sign. So if we have all the terms have the same sign, what's the result? 1. We are allowed to cancel them even though the position is wrong, But it doesn't matter. They just rearrange their position. We are so smart. We match their sign, and we know, well, they're same thing because they have the same sign. A is positive, A is positive. Did the sign change? No. B is negative, B is negative. Do you have different sign? No, same sign. C is negative, C is negative. Do you have same sign? So if you have same sign for everything, the result is 1. But for this one, let's say have A minus B minus C, and then B minus A plus C. Now what do you observe? We have same ABC, same ABC. So let's compare the sign. What sign A has on the top? What on the denominator? So you have different sign. How about B? What sign have we have on the numerator? But on the denominator? So same sign or different sign? Different. What sign C have on the top? And on the bottom? Same sign or different sign? So if you compare all three of them, do they have same sign or different sign? So can you cancel them? We can cancel them, but the result will be what? -1. If everything has different signs, we can cancel. But one has same, the other has different, then we cannot cancel. The cancellation has only 2 rules. Either you have to have same sign, same positive sign, no, same sign or opposite sign. These are the things. Everything have to have same sign, or everything have to have different sign. This is an example where everything has same sign on the numerator and denominator. And in this example, everything has different sign on the numerator and denominator. But if I give you an example like this, A plus B minus C, and then let's say C plus A minus B. Now you compare. What sign A have on the top? And on the denominator? So same sign. What sign B have on the top? But B have on the denominator? Different sign. So can you cancel them? One of them is same, the other is different. So cannot cancel.
Even if one side is different.
It cannot cancel. Exactly. It's not reducible. Same sign, but if you observe B, different sign, not cancelable. They have to have everything same sign or everything different sign. Leave it alone. It's prime, not cancelable. Prime. Prime means you cannot go any further. It's not possible. The next one. Great. So building upon this knowledge, we are going to do the next one. 2 terms, what type of factoring we do? The difference of perfect squares. Tell me again, what did you say? Nope. No. What comes first here? What do you see first? No, it's difference of perfect squares, but the factors are wrong. Whatever you see first, you have to write that first. We see 9 first, so we have to take the square root of 9 first. So square root of 9 is 3, so it is 3 plus y and 3 minus y. If you had y plus 3y minus 6, it's wrong. And denominator, we cannot do anything, so we'll leave it alone. Which one we can cancel? 3 minus y minus 3. After cancellation, what is left? So we have 3 minus y, and we have y minus 3. Are they same? They are not same. So you check their sign. 3 is positive here, but 3 is negative on the bottom. So different sign. Y is negative here, but Y is positive here. Different sign. So everything have different sign. We are allowed to cancel, but what do we get? Not 1, -1.
Leave the positive.
So we have -1 times 3 plus Y. This should be our final answer. Or
From the division.
You can just move it negative 3.1. If negative.
you can leave it, but if you want, you can also distribute. It's up to you. If you do distribute, it will be -3 minus Y. Both correct. If it's a multiple choice, you see which one you see in the multiple choice, and then you pick the correct one. Now again, if you're wondering why the answer is -1, the reason is this. We cannot cancel this way, so you have to factor out a negative from either from the top or from the bottom. So let's say I factor out -1 from the top. It means we have 3 minus Y. We are dividing by -1. This is what factoring means. So we got 3 becomes negative and Y becomes positive after factoring the -1 out. Denominator has Y minus 3. Now we have exact same two things. We cancel, but we left with -1. And that's why when everything has opposite sign, we can cancel them, but we end up getting a -1. Why? Because we actually factor out -1 from either one of them to cancel them. So this work is hidden. Okay? You don't have to show that, as long as you remember that if everything has opposite sign, you can cancel. The result is -1. And then we did equivalent expression, means you can put the negative on the top, on the bottom, you can distribute, or you can leave it. No, but you're allowed to put only one position, either on the numerator or on the denominator, but you definitely cannot put in both places. Okay, one more example with negative. We have y squared minus yx. How many terms we have on the numerator? How many terms we have? 4 terms. So which method? Grouping. See, you should know for how many terms, what's the method. For 2 terms, how many methods we have? GCF and perfect square. Good. For 3 terms, how many methods we have? Direct factoring and AC method, and if the numbers are too big, trial method. So for 3 terms, we have 3. For 3 terms, we have 3 methods. 2 terms, we have 2 methods. And for 4 terms, what's the method? Grouping. So let's do numerator. We have y squared minus yx minus 4y plus 4x. Let's group these 2 into 1, these 2 into 1. So what do you have in the first group? Y. Let's factor it out. What remains? So anytime you factor anything out, let's do the division this way so you can see what is left. What is left? Y minus x. Now in the second group, bless you. In the second group, what is our GCF? -4. So let's do the same thing again. -4, -4. So what is left after you factor out the division, after you do the division? Y minus x. And that's why most of you did not get the fourth term question correct in the exam, because you forgot to change the sign. Why did you forget? Because you did not do what I told you to do. Do the division visually so you can see what remains after the cancellation, after factoring. Now, if you compare both groups, what do you see in both groups? So you factor that out, and what is left? Y minus 4. So y minus x, y minus 4. That is the numerator. And now let's put our denominator back. 4 minus y. Can you cancel anything? First of all, y and x, they're different from the denominator. So y minus x, not be cancelable. How about these two? Do both of them have different sign? So can you cancel them? What will remain after the cancellation? -1. You can cancel different sign, but the result will be -1. So you have y minus x, no problem. But in the front, what do you have? -1. So this -1 is this -1 is from the cancellation. And we have y minus x from the not cancellation. So if you see this in the multiple choice, you leave it alone. But if you don't see this, then you can distribute, and we get -y and positive x. Positive x, -y. Four terms means two group. Yeah, lady? I'm going to give you at the end of the class. Okay, so with this, we are done with working with negative. And now we are going to do multiplication. So multiplying and simplifying are same thing. The only difference is when you simplify, you work with one fraction. But when you multiply, you work with multiple fractions. 2 fractions, 3 fractions, 4 fractions. In this class, we're going to work with only 2 fractions. Multiply 2 fractions. And just like we multiply numbers, just like we simplify, multiplication also have 3 steps. Factor everything possible, and then cancel whatever cancelable, and then rewrite. So can I flip my page twice? Let's refresh your memory with multiplying numbers. When you multiply numbers, there are several methods. One of the method is you multiply the numerator with the numerator, denominator with the denominator, and then reduce that. That is normal method. Also, there is a shortcut method. In the shortcut method, we don't multiply. Instead, we divide whatever is divisible. So we cancel by the division rule. For example, we have 2 on the numerator, 4 on the denominator. We can divide 4 by 2. So 2 and 4, they both can be canceled by 2. 2 goes to 2 one time, 2 goes to 4 2 times. So instead of multiplying them on the numerator, we actually canceled numerator, denominator. And how about 3 and 9? Can we cancel them? 3 goes to 9 how many times? 3 times. And 3 goes to 3 one time. Let me do it here so I can see the number. So once we cancel everything, what remains? We have 1 times 3 on the numerator, 1 times 2 on the denominator. So what is our final answer? 3/2. That's how we can multiply numbers instead of multiplying, but by reducing. We can use the same concept in rational expression. We have x plus 3 on the numerator. Do you see any x plus 3 on the denominator? We do. So we can cancel them. And then our numerator has x minus 1. Do you see any x minus 1 on the denominator? So we cannot cancel them. So we rewrite x minus 1 on the numerator. And what do we have on the denominator? X minus 5. Same question like before. Can we cancel these x's? Not cancelable. But why? Mora, do you at least remember now why you cannot cancel?
Because it doesn't have an multiplication sign.
Good job. In order to cancel, we have to have the next thing multiplication. But next to this x, what sign we have? Next to the bottom one. So if either one of them not have a multiplication sign, if either one of them have not multiplication sign, not cancelable. Because x's don't have multiplication sign next to them. We are only allowed to cancel in multiplication. We cannot cancel in addition, subtraction, or division. Only multiplication is the best one. So 3 steps: factor, cancel, rewrite. Can I flip my page? And I also posted this on Brightspace, the lecture notes, both in PDF format and also in Word format. Okay, let's do something easy first, like before. On the first one, we have 9x squared divided by y squared, and we are multiplying 3y divided by 2x. Nothing is factorable here, so we leave the factoring part alone, and we go to the cancellation directly. We have 9 here. Do we have any number in the denominator that can be divisible by 9, or that can divide 9? No. So 9 is not divisible by 2. We cannot use 3 because 3 and 9, they're on the same level. I'm looking at them individually. So 9 is a number. We are looking for any number in the denominator that we can reduce the 9. We cannot, so 9 is alone. Then we go to the x square. So let me erase my circle. Then we go to x square. We have x square on the numerator. Do you see anything on the denominator that can cancel our x square on the numerator? We have an x. So it's like x square on the numerator, x on the denominator. Can you cancel them? Of course we can. Remember the exponent rule? In division, what do? Subtract the power. So we can cancel x squared and x. What's the result? X on the numerator. Because 2 minus 1 is 1 on the numerator. Now let's go to the next one. So let me erase, let me keep it. Then 3. Do you see on the denominator, anything on the denominator that can cancel the 3? So we leave our 3. And then the next one is y. Do we have anything on the denominator that cancels this y? What do we have? Y square. So by the quotient rule, we can cancel them. But what is left? On the top or on the bottom? On the bottom. So we use the y square with y. We use x squared with x. 3 did not have anything to cancel. And at the end, we don't have anything on the for 2 to cancel. So we didn't touch 9, 3, and 2. We reduced x and y. So at the end, after all this cancellation, what is left on the numerator? 9x times 3. So when you combine them, the result will be 27x. And how about the denominator? Y and 2. So when you combine them, 2y. And this is our final answer. You definitely don't have to do all these things we are doing. You can simply do the cancellation directly. I broke down everything so I can show you how cancellation works. Now, without doing all the details, you can try the next one. Jannah, would you like to try? Yeah. So here 2, do you have anything on the denominator to cancel? 10. 2 goes to 10 how many times? 5. And then we have x squared. Which one you want to cancel? Top is 2, bottom is 7. So how many you get after the cancellation? X to the power 5 on the denominator. Do you have anything else that can be cancelled? We have 1 here, 1 here. So we have 5 and we have 5. As long as you have something on the numerator, denominator that is reducible, you can reduce them. So 5 cancel the 5. Go ahead. No, because they are all on the denominator. If we have multiple things on the same level, they all mean the same thing. You're confused? Let me try it another way. Okay. So we have 2, we have x squared, and we have 5, right? On the numerator. On the denominator, we have x to the 7 and x to the 1. So if you combine them, how many x's you have? How many x's we have? 8 of them. And then you have a number 10. You can put number 10 here, or you can put number 10 below 5. It doesn't matter what do you put, but it's on the denominator. Now let's simplify. 2 goes to 10, 5 times. X squared goes to x to the 8, x to the 6. And now we have 5 on the denominator and also 5 on the numerator. They cancel.
One be breaking both x to the power 5.
Because we cancel this way. 2 and 5, 2 and 7 cancel. So we get x to the 5 here.
And then like for the next step we do the other ones.
So we have 5 of them here, 1 of them here, total will be 6 of them, just like this one. So after the cancellation, what do we have on the numerator? 1, because everything got divided. And how about the denominator? X to the power 6. So this is one way of thinking. Look at all the numerators, look at all the denominators, and see if anything can be reducible. Now, these will not be in the exam. These are just baby steps. What will be in the exam? Not also this. Can I flip my page twice? Okay. What will be in the exam is something like this. So let's do the left page first. On the numerator, we have a square minus ab, and then 2a plus 2b. On the denominator, we have 2a and a minus 4 whole thing to the power 4. 2 terms. How do we factor? So which one works here? Good job. So what is our GCF? A. Once we factor, what is left?
A.
Great. And the denominator, we have 2a times the next one. 2 terms on the numerator. Which method? Again, GCF. What is our GCF this time? Once we factor that out, what is left? Wonderful. And denominator, we have a minus 4, a minus b, 4 of them. A minus b. Let's write it 4 times so you can see what is left. 4 of them means we have same thing 4 times. So we factored, now it's canceling time. We have a on the numerator. Do we have any single a on the denominator to cancel? So a's are reducible. We have a minus b on the numerator. Do you have any a minus b on the denominator? So we have 4 of them. How many can cancel? And then we have 2 on the numerator. Do you see any multiples of 2 on the denominator? So we cancel. Bless you. And then we have a plus b on the numerator. Do you see any a plus b on the denominator? No. That means you're done with cancellation. And now let's collect what is left. What is left on the numerator? A plus b. What is left on the denominator? How many of them? Good job. Ta-da! We are done. See, this is much easier than what we did last in the last example. So you don't have to write all the factors out. You can simply cancel one of them or how many, whatever we need, and then you subtract the remaining. Just like the example we did. We had x squared and we have x to the 8. So we cancel and we left with 8 of them in the denominator. Now I'm going to call 4 volunteers to give me 4 parts for the next example.
That would be for the exam.
Hmm?
That would be an exam.
So these are exam questions. Exam. Exam. Okay, let's start with lady. Lady, would you like to give me the 2 factors for the left numerator? Multiply to 24. Hmm?
Four.
6 and 4. What sign 6 must have? Positive, because the middle sign is positive. So if you want to get 10 from 6, are you going to add 4 or subtract 4?
At 4.
Add 4. Good job. Ricardo, the denominator. Multiply to 42. Okay, would you like to try this one then? 2 times, which method? Do you see any difference? Any minus sign? Then it cannot be difference of upper square. So it has to be GCF. So what is your GCF? Good. What is left? Wonderful. Nicholas, the denominator for 42. Multiply to 42. What 2 factors we have? When you see 42, you're supposed to see a number flash in your mind. 7, definitely. 7 times what? 6. Great. What sign 7 must have? Plus, because the middle sign is plus. Then if you want to get 13, are you going to add 6 or subtract 6? 7 minus 6 is 1. You need to add 6. Taj, the denominator on the right. Multiply to 36. It's not 6 times 6. Let's see, we have 36. 2 times what? 2 times 18. Do you get 5 by adding or subtracting? Then let's go to 3. 3 times what is 36? 3 goes to 3 how many times? 1. And 3 goes to 6? Twice. Do you get 5 from here? No. Then let's go to 4. 4 times what is 36? 9. Can you get 5 from here? So we have 9 and 4. Now decide their sign. 9 must be negative. 4 has to be positive. Good job, you got it. Nicholas I, would you like to cancel? X plus 6, X plus 6, X plus 7, X plus 7. X or X plus 4, which one? So you have a single x. Do you have any single x on the denominator? So you cannot cancel. But we still have x plus 4 left on the numerator. X plus 4, x plus 4. X over x minus 9. Okay, so that's how we multiply. We factor everything that is factorable. We cancel everything that is cancelable. And then we rewrite everything on their proper position. Now, division is same as multiplication. There is only one extra step. Keep, change, flip. Because we don't know how to divide. Can I flip my page? So the steps for division is factor first, keep, change, flip, and then do canceling and rewriting. Let me skip this. Let's go to this one. Oh, let's do the left one real quick, no problem. So we don't know how to divide, unfortunately. So we keep our first position. Always keep the left. And then we don't know how to divide, so we are going to change the division into multiplication. And since we are doing something without getting permission from anyone, so we have to give a penalty. Our penalty is flipping the right. So flip. In other words, we have 6x to the 8 over y squared. We keep that. We change the division into multiplication, and we flip the thing we have after the division. X to the 8 y squared. And now it becomes same as multiplication. So it's the same thing what we did in the multiplication. We have 6, we can cancel it 2. 2 goes to 2 once, 2 goes to 6 3 times. We have x to the 8, we have x to the 8, we can cancel them. Now, after canceling these two things, what is left on the numerator? We have 3 and 3. So that gives us 9. And what is left on the denominator? Y squared and y squared. So what do you get from there? Y to the 4.
I'm sorry. Did you flip the 3 so it can
We
be
flip the
divided?
right side of the divide sign. So before division, we don't change. After division, we have to flip.
Always.
Always. This is one extra step that is different from multiplication. Now this was easy, so this will not be in the exam. What will be in the exam is something like this. Nayari. Oh, factoring. Step 1 is factor. So which method? Difference of perfect square. So which two factors we get? X plus 5, x minus 5. Mora, would you like to try the denominator? This one.
It would be 6.
Multiply to 6.
6 and 1.
6 minus 1 is 5.
2
2
and 3.
and 3.
That would be -3 and positive.
3 has to be negative because of the middle sign. And if you want to get 1, you have to have the opposite sign for 2. Divide. RST, would you like to try the right numerator? Which method? The right. X cubed plus 5x squared. This one. It has to be GCF. In order to use difference of perfect square, you have to have a minus sign and two perfect things. We don't have any minus sign. So what is the GCF? Only x. We have x cubed and we have x squared. How many x's we have in both of them? Definitely two of them. So it has to be x squared. So if you factor out x squared, what do you have? No. From this one, you have x. And from here, you have plus 5. That's what I said. Do the math visually. We have x cubed plus 5x squared. Since you factored out x squared as a GCF, so you do this way. So you see 3 minus 2 is 1 and x squared cancel out. So you're left with x plus 5. You run out the denominator. The right denominator. Which method, GCF or perfect square? GCF. So what is our GCF here? And what is left? Perfect. So see, factor everything that is factorable, and now we are going to flip and change. So let me keep x plus 5, x minus 5, x minus 3, x plus 2, change the division into multiplication. We flip the right, and then we do cancellation. Who would like to have the fun with cancellation? Daniel. X plus 5, x plus 5. X minus 3, x minus 3. So you have x3 on the top, x squared on the bottom. Can you reduce them? What do you get? X. Now the fun is over. Then we rewrite. What is left in the numerator? X and x minus 5. X plus 2. You can keep it, or if you want, you can distribute that. You don't have to do the distribution, but if you want, you can. Now let me give you an example. Next class, so that's all about division. You factor, you change, and then cancel, rewrite. So in our next class, we are going to do addition, subtraction, and then solving. So our exam will be addition, subtraction, multiplication, division, and solving radical expression. Not radical, rational. Christian, Nicholas I. Rana.